Hey guys, this is your friend Mainak from Civil Center and welcome all for back to our channel another video on Tekla Structural Designer. So friends, in today's video we'll work on a new project in the Tekla Structural Designer software, and if you are bumping into our channel for the first time, make sure you subscribe to our channel, and if you want to take professional training on Tekla Structural Designer or any other courses related to civil engineering, you can contact us using the number which has been given in the description, and also you can register using the link which has been given to the description so that our team can contact directly with you. Okay, so having done that, now we'll be working on this project and we'll just check the requirements first. So as you know, before starting any structural design, you need to check the requirements of that particular building, and according to that you'll just provide everything. So first of all, here we have created a new file in Tekla Structural Designer. We need the height of the different floors. So the ground floor is 11 feet 6 inch. So if you convert it, this is 11 feet 6 inch means 11.5. 11.5 divided by 3.28, it is 3.51 meters. So the first level will be 3.51 meters. So we'll just go here, construction levels, and insert below, and the below level will take as minus 1.2 meters, that is for the up to the for the foundation level, and this is the plinth level, and we'll insert a level above it, and the spacing which will give is our 3.51. so 3.51 will be for our ground floor slab, and another level will insert above this particular level here, and this particular level will have 10 feet 6 inch. So 10 feet 6 inch will be 10.5 divided by 3.28, which is 3.2 meters for the remaining particular portion. So it will be, this one will be 3.2, and we'll also just change this to SSL, structural slab level, because it has a slab of, let's say, 100 mm, and here also 100 mm slab will consider first, later we can design and check later. So 3.2 meter for this ground floor, G+1, and let's see how much they're willing to go for this particular building. And there is number of floors for this particular building. Ground floor, first floor, second floor. So second floor will be of the same level. So this is G+1. We'll insert another level above it. So it is a G+2 building currently. This is the foundation level, plinth level, ground floor slab level, roof slab level, and then the first floor roof slab level, and the second floor roof slab level. Okay, then we'll just click on OK, and we'll start with our particular design. So first of all, we'll go and import the DXF. So what is the DXF file? In this, we have already prepared the centerline diagram of this particular building. So we had the building plan, and we had prepared the centerline diagram of it, and which contained the center lines of all the columns in different position, and the column positions are all decided by us, and according to the plan, and we will also now insert the beams and columns here. So this is the beam column plan which you need to make basically before proceeding with the this Tekla Structural Designer. We have made many videos on how to make this, how column positioning, column orientation, and how to make the beam column plan in AutoCAD. You can check out in our channel for that. So once we have done with the beam column plan, we'll just import a DXF file here. So we have already just checked the DXF file, and first of all we only need the center line, we don't need anything else. We'll import it as an architectural grade. Units is mm, because structural engineering units are mm. We'll just import it in bilayer all the levels. So once this has been imported, it will look like this, as you can see here, and after that you need to do this import DXF once again and open this, and after that you can untake the center line. We don't want the center line right now. We can import it as a shadow and import it in mm, and then click on finish. You can notice that, okay, first let us zoom it. So you can notice that we are working on the plinth level. So this is the plinth level which we are working on, and we'll insert our columns here. So it's important to know that this column wall size was 1 feet, that is 300 mm. So 300 mm columns will provide here. 300 to 300 will start with those set of columns here. So first of all, before just proceeding, just check the design settings here, and go to design and design settings, and we'll just go to the beam design first, because these are two elements which will design generally. beam, column, and then a footing. This three designs actually. So minimum bar size for the beams, firstly we'll do this FE 500, and the minimum bar size for the beams, which will give as, so we'll define the size of this, we'll define the bar size of 12 mm as the minimum bar size, and the maximum bar size we'll also take as FE 500, and we'll just put a bar size of, let's say, 20 mm here, and click on OK. And then for same for the columns, minimum bar size will be FE 500, and we'll go with 12 mm bars, and the maximum bar size here will be FE 500, and we'll go with 20 mm bars here. Click on OK and click on OK here. So this after this has been done, we'll just go to model, and or you can go to model here, and then click on the columns, and then create a column size of let's say 300 to 300, and we'll just go over here, and to the section we'll just create a new section here, and the size which will give us 300 into 300, and then click on OK. And then automatic alignment we can turn it off, and at the center we'll do the grade of the column FE 500 we're going to select here, and after that we'll just click on save. So we'll name it C300 cross 300, and then click on OK. So after that we can place the columns in all the locations which we want, and which has been already specified in our drawing. So we'll do that here, here. So and this we are placing this at the plinth level, the columns. So we'll have here, and here, and more columns here and here. The next row, let's check, and here also one. So this is the columns which we are having. Okay, no, not here. So we are having delete this, or we can press Ctrl+Z, and then take columns again, and then just select the size which we are providing, and after that we'll provide it here. So after this has been provided, we'll move on to the next layer. This is the layer 1 2 3 4 okay. So we have one here also, 5 6 7, then this layer 8 9 10 11 12 13. Okay, so here are the columns. Let's also cross check once again. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19, and then 20 21 22. So here 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. So we'll go good with the counting, and since we have 300 and 300 this columns, because we have basically are using a 1 feet thick laterite bricks at the plinth level, so that's why we are using this. That's why going for the thick columns. So we'll be at the plinth level, we'll be providing beams also for that size only. So it will be 300 into your go 300 and 350 first, and 300 into 350, or let's try 300 and 300 first, or that. Okay, we'll go 300 350, and here just this FE 500. Let's do this FE 500, and then we'll just save this B 300 into 350 for the laterite stone blocks. Now let's join all the main beams first. Don't have to worry about the secondary beams right now. This one we need to give definitely. Join this. Secondary beams, if we just finish the work of changing the releases, it will be good. So this one, as you can see, this one was, the bottom one is end one, and the bottom end one is your pinned and two is your fixed. Okay, and here also this end one will be fixed and end two will be pinned. For same for this case also, end one will be your pinned and end two will be fixed, because this one is end one with the column, this one we don't have any column. So for all the secondary beams we can do like this. Here also actually, here also you can just go over the beam and take this property and do it here. Releases, fixed and pin. So we're good with this we're talking about this beam, and the remaining ones, the ones which you have the column to column connection, we'll just do that. Beams, this is the beam which you're having, done. Next is this one, done. Next, if you want to do this, you need to do as secondary beam. So this one will be pin and fix, because this end is end one, pin, and this has a column, so fix. Now let's check remaining ones. Beam, we have columns here, and let's check if we need to give any secondary beams, kind of any secondary beams. Here you can give a secondary beam here, and the other beams, as you can see here, all are primary beams, so there's no problem in that. If we want to join this, it will be beam like this. Just click on escape and complete this. Actually this will be your, both the ends will be, this is the beam, both the ends will be pinned here. So here we'll just select the releases and go to pin here, and here also pin. And for this particular beam, as you can see, the first end will be fixed and the second end will be pinned. Left to right, we're going from left to right. Left one is first one and the right one is the second one. So after doing like this, we'll just proceed with the next step. And for the next step, we are selecting the beams here, and here we are going with the selecting of this particular beam, and we'll just select this and then select this, and this we have a secondary beam here. So we'll just draw this beam and double click on it, go to releases, left end will be pinned and right end will be fixed, and beam, this selected this beam, and here also, as you can see, we have a column here. So this is it, and we'll validate the model if we have any error. So validation is okay. You can check in the structure 3D, the particular beams have been made, and after that what we can do is we can simply just go to model, go to construction levels, and go to level 1, and the level 1 source we can make as base. As you can see, the beams will be copied, and then after that we'll just do this as unique, so it will make, so that if we make any changes in all this floor, it was the base or the plinth is not affected. So here quickly, here we don't have any particular, all the walls which will have of all the walls which will have will be your thinner, because we'll use fly ash bricks or red bricks here, red bricks. As you can see in the requirements, here fly ash red bricks will be used, so 10-inch walls will be there. So in this case we'll just go a bit lower for the section. So the section will just do this as 250 into 250 into 300 first, and if it fails then we can go for the higher sections as well. So we'll just go with this section, and after that we'll just go to the structure base, or rather we'll go to the structure window, levels, and move on to this structure 1. So after that please remember, here we have a staircase. Apart from that, just put this slabs in positions. One way slab is not designed in it anyway, so you don't need to worry about one way or two way. Provide two-way slabs because we are just providing it for the loads. Okay. So after this has been done, what you can do, we'll go to construction levels, and then make the source of this 2 as your 1, and go to construction levels, make this unique, and make this source as 1. Okay, go to construction levels and again make this as unique. So after this has been done, model has been created, and after the model has been created, you can validate it once again to check whether you have any errors or not. So we'll go quickly apply the loads here without wasting any time. Just to take the dead loads, loading, and fully UDL for the laterite stone blocks, we'll go with a load of 14 kN per meter, and we're applying the loads for the laterite stone blocks here, dead loads in the exterior walls, and all the exterior walls we can apply that particular load. For the staircase, it will be in all the sides, and if you can check the plan, it is pretty much the laterite stone blocks in all the floors inside also. So we'll just apply the same load everywhere, but these walls will be thinner. Even if it is the laterite stone blocks, it will be thinner. So we'll just go with a load of 7 here. Internal walls, so after having applied these loads, we'll just go to check in the structure 3D the dead loads. Okay, so go to the next level, that is structure 1, and here we'll just go to loads and just click on escape twice if any program is coming. So just select the dead load here, full UDL, and here we have fly ash bricks, so we'll just go with a normal procedure, 11 along the external walls, and 5.5 for all the internal walls for fly red bricks. And after that, go to structure 3D, check, and then go to live load or imposed load, and apply a level load of 2 kN per meter square for the residential buildings. And after that, go to structure 3D, just check the imposed load and go to the model and go to construction levels. This 2 source, make this as 1. Okay, and after all the loads are copied, you go to the construction levels and then make this source as unique. And after making this source as unique, we'll again go and check whether the source is unique or not. Okay, it's done. And after that we'll go to the next or the last level, and here what you can do is you can apply the dead loads. So for applying the dead loads, we'll go to loads, select the dead load here, full UDL, 11 per kilonewton per meter for the staircase portion, because we will have a 10-inch wall here. Remaining will only for the loading for the parapet, so 2.5 for the parapet wall. So you can, and live load, imposed load, take a level load of 2 for the residential building, 2, and go to structure 3D. This is the imposed loads, this is the dead loads. As you can see, the magnitude is also shown very properly in the software. So since this is a G+2 building, so no seismic loads, or no wind loads will be considered because it's below the 10-meter height. And then we'll simply go to the loading part, and this seismic wizard will just activate that. So you have the seismic load, seismic wizard, and then you go the code spectra, and all this are taken automatically. Just ignore seismic below the plinth level. Importance factor is 1 for the residential, and zone, it's Bhubaneswar, so it's zone 3. And we'll go with the model response spectrum analysis as we always go. Type of building, RC, moment resisting frames for this type of buildings. Type moment frame systems, and this also moment frame systems. Click on next. Take all the live loads and dead loads into considerations, and click on next, and then click on finish. After that, we'll create some load combination according to operating, and then click on next. Select all the load limit state combinations if you are going with the Indian codes, or else in the different country codes this thing is different as per your code. Click on next and click on finish. And after that, we'll create some load combinations and generate some load combinations of your operating, and click on next. I'm including the limit state combinations. Again, as I tell, this particular loading part for the combination is different in different codes. You can select wisely. Then click on next, and then click on next again, and then click on finish again. Just click on OK, and after the design has been done, and validate your model once again. If all are green, then you're good to go, and then click on design, and then we have this option of design all static. So after the building has been designed, as you can see, some members are failing. So you can have the freedom of increasing the size of those particular members, and so that you can achieve a safe design. So if I look at the columns, only I think 2 columns, so we can change the size of it. So if we just check, right click on it, and then design members, so it's showing that let's check. Okay, so it's not enough basically. So let's check this particular column, which orientation it might have. So I have the option of increasing it in along this side. I think if we just check the particular orientation, I think this is the column which we are talking about here. So it is pretty much this 1 2 3. So 1 2 and 3, this is the column. So let's give it an orientation here. As you can see here, this is the orientation. Let's give the orientation like this and check whether this makes any difference. So the size, and I'm going to change the depth here, go to 350, and then check if this makes any difference here. Right click on it, and then design member static. Still it's better, but still it's failing. So let's go with the alternate arrangement, C15 to 300. Let's see if this helps. Right click and design member static. Okay, so it's passing. So this was the correct orientation for this. As you can see, it's passing, so it's good. And here also, what will be the orientation of this, you need to decide. Let's go with 350, same thing, and then check 315 to 300, and then right click on it and design member static. So it's passing, then we are good to go here. And for the beams which are failing, we can increase the uh, size also. Okay, so let's go with the beams of one section, because all the loads, as you can see, are the same. So if you can pass make the beams of one particular floor pass, then the remaining will automatically follow. Just turn off the loads here, and this one as well, this one, this one, and this one. Okay, so what's the next size for these beams? 250 to 300, so definitely 250 to 350 is the size to go. And okay, and then right click on it and design selection static. So we have the option of design selection static, and we'll check whether we have made any difference or not. Okay, massive difference we made. Select this, select this, select this, this and this. Okay, let's select one member and just check what is the problem here in this design. Okay, sections, it has sections problems, so we might need to increase the particular size as well, the other dimension as well actually. So because it's the case of section, so let's go with 300 and 350. Let's check what happens. Right click on it and right click design selection static, design selection static, and I think okay, we're better here, but still we need to work on it. This thing, these columns, I think we'll go with 300 to 400 for this, and then check. Right click and design selection static. Okay, so if still failing, it's some problem here, so let's see if we can sort it out. So why is failing? So okay, that it's actually, this is the good news, that it is this it's safe for the moment. So only in the longitudinal bars. Okay, it's not safe for the longitudinal bars as well, because it's failing actually. So let's try making this pass. I guess the remaining one will also take the same design, so we'll just make this happen first. So let's try with this 350, but let's see if it works. Okay, one member has passed now, one member is still failing. So what can we do? Let's go with the next size, 350 into 450, and then check. Right click, design member static. Still it's failing, and only failing in the longitudinal bars, as you can see. Section inadequate for torsion, and whether we can just increase the section if it's inadequate for torsion. Right click and design member static. Okay, it's passed. So this particular design, 400 into 450, we can copy in all, so that we can, this will be a 400 into 450. Right click on it and then design selection static. So we're good to go here. So the particular load is the same for this particular floor as well. So if you take the same size, so it will pass definitely. And this sections also, the sections which are failing, for the plinth beams also, we can increase the size. It is 300 and 350. We'll go with the next size, 300 into 400, or rather 350 into 400, and then check. Right click and then design selection static. This is safe. Plinth beams, about plinth beam warning, why it shows always warning, I've made a video, so you can check that out. But we are